Okay, and that is quarter past the hour. Welcome, everyone. And this is our first session of 8KB August 2022 with Angela and Partitioning, the good, the bad, and the ugly. Take it away, Angela.
Thanks, Andrew. My name is Angela. For those of you who haven't heard my very infrequent presentations before now, I'm a DBA by trade, but I used to belong to the dark side, aka DB developer. Sorry, guys. I work in SQL Server, so this presentation will be from a SQL Server standpoint. So please don't ask questions about Postgres or any of that because I don't think I can answer. I'll be going into a very high level of SQL Server partitioning, go through some of the concepts and of course the gotchas, because yeah, there's good, there's bad, and there's ugly. So we'll start with a high level view of partitioning. Like, what is partitioning? I'm sure some of you are very familiar with SQL Server partitioning, but for some, this may be a new concept. So I'll try and have something for everybody. I apologize if I do put anyone to sleep, but I hope this does prove to be an informative session for most of you anyway. So what is partitioning? Basically, as the name suggests, SQL Server partitioning is where you break a very big table down into smaller parts or partitions. That's sort of what is as simple as the explanation can be. You have different types of partitioning. What I'm going to be talking about here is horizontal partitioning, where you're breaking it down, you're dividing it by row. You do have a concept of vertical partitioning, where you divide by column, but out of scope for this session, but it does exist. Horizontal partitions, any examples I reference will basically be using dates, since it's the most commonly used, I guess, use case for horizontal partitioning. But you can partition by anything that you need to. Most data types will work. Just a note on the vertical, if you are doing vertical partitioning, you do need a link between your tables or your columns. Just make sure all the data stays tied together. But here we'll focus on horizontal only. It's the most widely used. So yeah, let's get into it. So we'll start with the good. What are some of the benefits of partitioning large tables? Because there are many benefits when used properly. There's gotchas, of course. We'll cover those as well. Nothing has only one side. So one of the key benefits that everyone talks about when talking about partitioning is speed. You can load data very quickly. There's a concept called partition switching, which I will go into later in this presentation, commonly used to load new data into large tables. You can also unload data. This will be used for archiving of old data, or if you don't have an archive, if you simply want to delete old data, you can use partitioning and partition switching to do that very quickly. And in today's world, especially in the EU, where you have the concepts of GDPR and data retention, this is a very useful tool. Another reason for partitioning, which I should mention is more an added bonus and should not be your primary reason for implementing partition, it can improve query performance significantly. Note, can. It can have an adverse effect as well if used incorrectly, but when used properly, you can actually leverage some pretty good performance benefits from partitioning of large tables. Large tables being the key. It's generally not recommended to partition a small table. A static table, you're going to get no benefit. Large tables, transactional data, these are the kinds that are generally candidates for partitioning. And hopefully I'll cover some of the reasons why as we go through this, make it a little clearer or more muddy. I don't know, hopefully the former. So sticking with the benefits of partitioning large tables, in addition to what I mentioned previously, you can perform index maintenance on individual partitions. And when your table is huge, we're talking multiple 100 gigabytes into the terabytes, this can be invaluable. You don't want to be doing a rebuild or a reorg on an entire index spanning the entire table. It could take hours. It's going to absolutely kill your memory, kill your CPU. But when you can target individual partitions, you can break down your maintenance into more manageable chunks. You can also apply different data compression to different partitions. Now, there'll be use cases where you may or may not want to use this, but the option is there. You can control this at a per partition level. And data can also physically reside in different folders or even different disks, different volumes on your server. Now, there's many different designs you can use for this, many different reasons you may want to move your data around. For example, you may want to put your active, your current data on your fastest but more expensive disks, and the old data that people very infrequently access, you can stick it on the old cheap slow drives. So loads and loads of benefits when you are using partitioning, but no single one of these should be the driving force. It should be a combination of factors. Partitioning should be a carefully considered and thought out strategy. Don't use it just because, hey, I've got a big table and someone said partitioning is good. Now, we've mentioned some of the benefits here, but of course, with anything, there are gotchas. There are rules, there are pitfalls, and you need to be aware of all of them in order to implement a good, robust, efficient partitioning strategy. So we'll look at some of the gotchas. So first thing to keep in mind is there are lots of rules around implementing a good partitioning strategy, specifically when you want to leverage partition switching to load or unload data into your tables. And by lots of rules, I do mean lots and lots of rules. I've included some links at the end of the slide, and I will upload this slide to the GitHub repo after the session. And these rules there's a couple of different blogs as well as a Microsoft site which lists out the various rules which need to be met in order to do partition switching. Partition switching or partitioning can have a negative impact on performance if your queries are not written properly, which is why I mentioned that partitioning should be implemented not just for a single reason, and definitely not just for, hey, partitioning improves performance. It can, but this should be sort of a bonus of using partitioning. You have to write your queries in order to leverage the partitioning correctly to reap the benefits of the performance. If you don't, you're going to feel some pain. And if you are implementing multiple different partition strategies on different tables in your database, it can add complexity to any automatic maintenance that you do have. If you're using different data types, different ranges, all of this, any sort of automation has to take into account every strategy. So the more you have, the more complex it becomes, as with anything in life, I guess. So sort of, yeah, that's okay so far. If anyone has any questions so far, please fire them away. Otherwise, I will just plow ahead. This isn't going to be a super deep dive, but I'm kind of going to touch on some of the concepts of partitioning. And hopefully these are at least slightly familiar to many of you. So some of the concepts that you will hear whenever you're talking about or researching partitioning: the partition function. this is one of the core objects in partitioning a table in your database. The function is what defines the partition structure, the number of partitions, how the rules kind of split the data. Does it go, is it an equal to, or is it an inequality? Links to the boundaries. All of that is driven by the partition function. And this keeps a hold of all of the partition ranges for your various tables. Building on top of your partition function is what is called a partition scheme. The partition scheme is kind of a link that maps the partitions to the file groups and the indexes. The function can be a shared object, but obviously each index in each table is going to be storing its data individually, and you can leverage files and file groups in your individual table, and your scheme is kind of in between, keeping everything linked together. In an index, every partition within that index can only have one file group, which can have multiple files, but you can have multiple different partitions in that index, and each of those partitions can have a different file group. And this is where you can start physically splitting your data across disks, across folders, and distributing the load, dividing it based on usage. You may also want to consider using different partition schemes for your data, your clustered index versus your non-clustered, different access patterns, and also just keeps things nice and clean and nice and neat. So you can have multiple partition schemes referencing the function, and your table can reference multiple different partition schemes. So it can get as simple or as complex as you want to make it, basically. When you're talking about partitioning, you're going to hear the word or the term partition column or partitioning key thrown around a lot. This is the column on your table that is used to partition the rows in that table. One of the most common ones, as I mentioned before, it's date, because it's used in most transactional data, whether you're referencing sales, financials, anything that happens on a timeline, anything that has a date. The date column is usually a good logical candidate to partition the data on. It makes sense. You group it by year, you group it by month, but you don't have to use the date. You can use any column that fits your particular scenario. Most data types can be used in your partition key column. Another thing that's going to come up a lot when you're looking at partitioning is aligned versus misaligned indexes. Some of the links that I've included will have more details on what are aligned indexes and why they are good. The short version is indexes must be aligned in order to enable partition switching. If they're not aligned, your switch is going to fail. So what are aligned indexes? This is basically when your index is built on the same partition function, and therefore all of your partitions for your different indexes for this table have your partitions in line. So they've got the first partition has the same boundaries, the second partition has the same boundaries, etc., 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 all nice and neatly in a line. You can also have, it's not recommended, but it's possible. It works when you have two different partition functions or multiple different partition functions, one for each index on a table, but you need to be more careful and more dedicated into keeping the partitions in line of the various functions, or you're going to run into problems when you are switching. So your number of partitions has to be the same, your boundary values, your data types has to be the same in order to do a successful partition switch. Rules, lots of rules. I'll go through some of those as we go along. So when we're talking about partitioning, partition elimination is what I mentioned earlier when you're looking to leverage the performance aspect of partitioning. So you've got a very large table, you have multiple partitions. Say it contains transactions that are split by date. You're going back over 5 years and you split it monthly. So you've got 60 partitions with data. Partition elimination is when you write your query in such a way that the optimizer can target one or very few specific partitions and essentially eliminate the rest from the search when you're trying to find the data for your query, for the data in your predicate, hence partition elimination. If you're targeting a single row, you want to hit one partition, not scan through all 60. The less data to search through, the quicker the search will take, and this is where the performance benefits come in. And when you do not provide the partitioning key in your query, the optimizer isn't able to do this partition elimination, and it's got to scan through the entire table. And when your data is split across different files, potentially across different folders, potentially disks with better and poorer performance, your overall query can suffer if you are not using partition elimination. Therefore, always write your queries in such a way to include your partitioning key. This is why the design is super important. You can't just slap a partitioning strategy onto a table. It has to be thought through. How are people going to be using this table? How is it going to be queried? Is the candidate for the partition key something that can actually be used in most, if not all, queries on this table? Does it make sense to partition on this column? So lots of consideration goes into the design. Partition elimination should be at the forefront of your mind because of the impact on performance of your queries. So more to consider when you are designing and implementing your partitioning strategy is the type of partition function to use. Partition functions use ranges of values, so values between X and Y, and you have a concept of a range left and a range right. And what this does is it determines on which side of the boundary a record will fall if your partition key is equal to one of the boundary values. So I'll just use some numbers here just to make it easier to read, make it simpler. And I've compared a range left and a range right. So we've got 3 boundaries in this case. We have 0, 10, 20. It's cool, it's nice and simple. So in both cases, if you have a number, if you have a key that is less than 0, where's it going to fall? Well, it's going to fall in your very, very first partition on the left-hand side of the 0, because in your range left, less than or equal to 0 will fall into partition 1. In your right range, less than 0, so -5, easy, partition 1. If we're looking at +5, well, it's between 0 and 10, so partition 2, dead easy. But where does 10 fit in? This is where left and right is going to make a difference. The number 10 is the boundary value in this case. It's the second boundary value over here. When you have a left range, the rule says this value, anything greater than my left boundary and anything less than equal to my right boundary will fall into this partition. Since we don't want number 10 falling into both partitions, especially if you have physically different files, it's not possible. It's got to belong somewhere. So with the left range, the number 10 would fall into partition 2 because it is less than or equal to 10. But in a right range, the boundary says, well, it's got to be greater than equal to 0, but less than 10, and therefore the number 10 will reside in our third partition. When it comes to using dates, most people will use a right range for simplicity. If you think of monthly partitions for your sales, you have the 1st of January, the 1st of February, 1st of March, etc., etc., etc. Depending on your actual date strategy, whether you're using the datetime 2, datetime 3 with a 0 scale, with a 0 precision, or with a 7 precision, trying to do a less than equal to can be fairly difficult to ensure that you capture everything. Whereas if you are saying, well, all of my dates greater than the 1st of February and equal to, and all of my dates less than the 1st of March go into the February partition, well, now you're catching the whole of February. Greater than or equal to Feb 1st at 0000 midnight, less than or equal to 1st of March at midnight. Super simple. Like you could use a range left, but for dates specifically, range right, it's cleaner and it's just a lot easier to get your head around. But this one's definitely a big pitfall, and it does confuse a lot of people. And even I've got to stop and think from time to time, like, the left, is it going to fall there? Is it going to fall there? Where is it going to fall? Lefts and rights, they're important, and they do make a difference as to where your data is going to physically reside. So that's sort of the design of your partition. Where, how, what. Now you've got this partitioning, everything's in place, it's cool. So now we want to use it for something awesome. And the most awesome part of partition switching, sorry, yes, I'm a geek, or partitioning, is partition switching. Partition switching is a very, very powerful tool if you use it to the full extent of its capabilities. Partition switching can move, and by move, I do not mean physically. It can logically move very large amounts of data very, very quickly. Think trying to archive off the whole of 2016 because it's now expired its data retention policy. If you're trying to delete an entire year's worth of data, that could take a long time, depending on the volume of your data. It can take a very long time. It can cause massive lock-in and block-in, whereas partition switch operations are near instant. This is because they are metadata operations. They don't physically move the data. They are basically just repointing the data. So while there is a very brief transaction and a very brief lock, it's so quick that us human beings don't even notice it's happening. But because it's a metadata operation, there are a lot of rules and restrictions put in place to ensure that it can happen. If the data is physically residing elsewhere, obviously you can't do a metadata switch. You're going to involve data movement, and your partition switching is not going to work. There's loads and loads of, well, there's loads and loads. There's a couple of different types of partition switch you can do. And one of the links at the end of this table, at the end of the slide, is actually by Catherine Wilhelmsen. Probably messed up her surname, but yeah, she's got a lovely blog on partitioning, partition switching, and various types of switching. I've just kind of grabbed the high level. So you can switch from an unpartitioned table into a partitioned table, and this is commonly used when loading data from a staging table into your main data as part of an ETL process. Can be used in a data warehouse situation, or even just a very large transactional database. You can load your staging table using whichever tools you want, SSIS, T-SQL, load them, do any transformations you want. No one's going to be accessing the staging table yet. Once that staging data is ready, the switch to load the staging table into your main table, if everything is done right and follows the rules, it's near instant. 1, 2, 3, boom, you've got your new month's data in your table. Magic. No, rules. We'll go through how some of that works later, but that's one of the, I'd say, more common usages for partition switching. Another very common use would be unloading your data. So you're going from a partitioned table into an unpartitioned table, like staging table. And this is commonly used for archiving. So in the same way as you've loaded in an instant, an entire partition, an entire month into your main table, you can now switch that whole month out of your table into a staging table, which can then be used to copy the data, taking its sweet time into an archiving system, or if you don't archive, if the data just gets deleted when it's no longer needed, truncate or drop your staging table, and the bulk of the heavy lifting gets done on the staging table, and your main table can go about its business with no performance impacts from that maintenance operation. You can also switch between two unpartitioned tables. That's, of course, not partition switching. That's just plain old switching. But yeah, it can be done. I won't spend any time focusing on that here because we're looking at partitions, right? So.
Hey, Angela.
Yeah.
Real quick, we had a question come in from the Slack channel.
Yeah.
Mark asks, how the heck do you switch data from unpartitioned tables when there is no metadata to utilize?
But there is metadata, and this is where the rules come in. So I do have a section there. There are a couple of additional requirements when going from an unpartitioned table to a partitioned table, but in and out, a lot of the same rules do apply. The metadata we're talking about is things like the file groups it resides on, which obviously is linked to the physical location of the data. The tables have to be identical. There's a lot of very, very specific rules that make this a metadata operation. But yeah, I'd say the key here is that they have to reside in the same place, on the same file group. And this is where SQL Server can then do a pointer from the partition to the table, or from the table to the partition, when it's saying, here, this is where your data is. And that's what the switch operation is. So if you've created your staging table on your primary file group and your partition table lives on a dedicated file group, it's not going to switch because your file group metadata is different. So I do have a section where I kind of detail that a little bit more. So if we want to come back to that question once we get to the partition switching rules, if it's maybe still not clear at that point, we can dive a little deeper into that. But I hope that kind of just high level makes things less murky for now.
Sounds good. Thanks.
I see there's a couple of replies there. Cool. Yep. So I've got the Slack on the background here as well. Multitasking. So we're going to stick with partition switching. Well, we're going to get back to the switching in a little bit. So like I say, I've got all the rules. I'm going to have all the rules listed out, and there's a couple of slides just with these. Right now, I'll just finish up on the different concepts in partition switching, or in partitioning. Sorry, I'm obsessed with partition switching for some reason. So when we're looking at partitions, we generally talk about the partition ranges, the individual partitions, their boundaries. And obviously, as you go along, you want to create new ranges. You want to remove old ranges that are no longer needed. And if you look at the date scenario, it makes it a lot clearer. As you move forward in time waits for no man or woman or person. as you move forward, as your data progresses onto new data, you want to create new ranges to cater for the new data. And this is called splitting. Splitting is essentially going to take generally your rightmost, your newest partition, your range, and it's going to create a new boundary in it and split it into two, thereby creating a new partition. So you've now got whatever your partition count was plus 1. Dropping a partition is called merging. It doesn't actually, there's no object to drop. It just removes the boundary date and merges 2 partitions into 1. Both of these, if the partition you are splitting or merging already contains data, and if that data would fit into the new partition range you're splitting out, or would have been in the one you're merging from, it can result in movement, like physical movement, if you have different files split across your server. Data movement is slow. Data movement can cause lock-in and block-in. So when you're doing splits and merges, it's recommended that the partition you're splitting or merging be empty, because then it's near instant. But your splits and merges are the way you're going to manage your different partition ranges, your number of partitions, and create new boundary values. And when we're talking about splitting and merging, we have a concept here, the last concept, I promise. We will move into the fun bit next, partition switching. There's a concept called a partition sliding window. And essentially, using the dates sort of example again, you want to maintain, ideally, a fixed number of partitions over time. So using the 5-year example, you want to keep these 60 partitions, the 5 years going. And as time moves on, you want to merge off older partitions and split newer partitions, but maintain that 60 partition window. So this is going to be a sliding window. It's going to keep moving forward into the future. It's going to slide. Splits and merges, splits and merges. This is easy, very easy to automate. There are loads and loads of blogs and tutorials out there on the internet to guide you through automation of partition maintenance. It's done every day by loads and loads of people, and it's a good thing to have. It keeps your data nice and neat. You don't end up with 1,000 old partitions. You keep your required window in place. Definitely don't recommend that you do this manually on an annual basis or whatever. Automate it wherever possible. And the sliding window, automation it's very, very doable. When we're using a more complex partitioning strategy like different file groups, that can obviously add complexity to maintaining that sliding window using automation. It doesn't make it impossible. It just requires a little extra coding, a little extra thought. If you're using an incremental file group 1, 2, 3, 4, 5, and into infinity, or more commonly a round robin file group. There's 12 months in a year. If you only have a year's retention, do you really need 500 files? We can just reuse those same 12 files. File 1, we use for January, file 2 for February, so on, so on, so on. Once you get to December, you're writing to file 12. The next January, you roll over into file 1 again, and you just keep reusing them, and it keeps your disks neat, it keeps your storage neat. You don't have to worry about shrinking or dropping unused empty files. Reuse, recycle. Doesn't just apply to real life, it applies to SQL Server as well. And there's loads of different ways in which you can implement the file groups, but whatever you're using, keep that in mind when you are automating your partition maintenance. The more complex your implementation, the more complex your maintenance. So yeah, that's kind of the high level what is. Now we get to the fun part. Switching. So I mentioned there are rules. And there's a few slides of rules, because while partition switching is a very powerful tool, it also requires things to be just right. It's easy to make it not work. And especially when we're talking about metadata, these rules are in place to ensure that everything is where it should be before SQL Server will allow the switch to take place. So what are some of the rules that we need in order to switch? And this is going to apply whether we're going partition to partition, a staging table to a partition table, or a partition table to a staging table. These rules, most of these rules apply to any switching scenario. So first and foremost, your source and your target objects have to exist. Partition switching does not create objects. You've got to first create your table before you can switch into it. So that one, I think, is kind of straightforward and self-explanatory. Very important one, wherever you're switching into, whether it is a table or a partition, it has to be empty. If you have even one record in your target or receiving partition or table, the switch is going to fail. It has to be empty because of the pointer. It's not moving the data, it's simply repointing. Your source and your target have to be identical, asterisk, 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 because obviously partition table is not the same as non-partition table, but by identical, I mean your columns have to be the same. Your data types have to be the same. Your column order has to be the same. The nullability has to be the same. If you are moving from one partitions table to another, your partitioning key has to be the same. Physically, it must reside on the same data file. So therefore, your file group must be the same. So if you are going from a partition table into a non-partition staging table, that staging table must reside on the same file group as what that partition is using. So even if your table is using 24 different file groups to cover 2 years, whichever staging table you're using to switch in or out of has to be on the same file group as the partition that you are switching in or out of. So you'll find that a lot of automation will create your staging table dynamically so that it can read the file group from your metadata or your sister file group's metadata in SQL Server and create it in the correct location. It's probably one of the more robust ways of handling that. And this is where I was talking about the metadata operation. All of this is metadata, your table structure, your file group, all of this metadata has to match. And if you have any indexes, your source and your target have to maintain the same indexes, clustered indexes, non-clustered indexes, constraints, defaults. Obviously, if you're going to or from an unpartitioned table, the index won't be partitioned, but other than that, it has to be identical. Your key columns have to be the same. Your included columns have to be the same. So basically, whatever you're going to or from has to be as identical as possible in order for SQL Server to repoint where the data is coming from. But those aren't the only rules. It would be too easy if it were. 4 rules. So when you're switching to or from a partition, if you're switching to a partition from a staging table, the data in your staging table has to match the boundaries of the partition you're switching into. It has to fit within those boundaries. So this is where the left and the right range is going to kind of come into play when you're automating this, which is greater than equal to, which is less than equal to, greater than, less than. Your source data has to fall within that target partition. It cannot be greater than the boundaries and hit 2 or more partitions, or it's going to fail. So you switch into a partition at a time. You don't switch into a range of partitions in one operation. If you are switching from a staging table unpartitioned into a partitioned table, then you have to have check constraints on your source staging table, which will basically tell SQL Server that, yeah, okay, I can confirm that my source data is going to fit into this single partition range. The switch is going to be possible. If you have any foreign key and check constraints, both source and target need to have the same constraints. And here's a concept that it's mentioned on the Microsoft documentation, but I don't think it's given maybe enough of an importance, like bold, keep this in mind. Your indexes have to be aligned in order for partition switching to take place. Now, what does aligned really mean? It means that if you have a table with multiple indexes and you decide you want to partition this table, all indexes must be partitioned. You can't have your clustered partitioned and your non-clustered unpartitioned, or have that one unpartitioned. Every index has to be partitioned, and every partition has to be in line with regards to the number of partitions and the boundary values for every partition. The easiest way of doing this, and the way that I would recommend myself, is using a single partition function for the table. So any indexes on the table, whether you have 1 index or 20 index, you should reuse that partition function for that table. You can reuse a partition function for multiple tables. That has its own sort of considerations and gotchas, but it is possible. But at minimum, have one partition function for one table and have all the indexes on that table use that. Then you will never have to worry about your partitions becoming misaligned. If they're misaligned, your partition switching will fail, because now you're not moving it like for like, especially if you're going to an unpartitioned staging table. So get some water there. And if you're using foreign keys, the table that you're switching out of cannot be the primary key for the foreign key relationship. It can't be the master key, because if you suddenly switch this data out of the table, your parent-child relationship is broken, whichever tables are referenced in the foreign key no longer have the parent key, because it's just been switched out. So therefore, it can't be a parent in a foreign key relation. Obviously, it can contain foreign keys pointing to others, but it itself can't be the parent key. Lots of rules, and we're not done yet. But I hope this is becoming clearer rather than murkier. It gets as simple or as complex as you decide to make it. So this first one over here is something that I've never actually tried myself. Replication, I don't tend to get along in general. I just never seem to have much luck with it, and I've definitely never tried it on a partition table. Microsoft's documentation states that replication is by default disabled on partition tables. However, it can be enabled. And there is a link in the slide to the Microsoft article on this. There are a lot of additional rules and gotchas when working on replicated partitioned tables. It technically is possible. I've never tried it. I don't want to try it. Replication scares me, to be honest. But yeah, there are ways and means. When you're partition switching, because it's a metadata operation, insert, update, and delete triggers are not fired. So if you have anything relying on these triggers, keep that in mind when performing partition switching. Microsoft states that you can't have full text or XML indexes on your source or targets tables when doing a partition switch. Never tried these myself, never had any use case to actually use full text or XML indexes, but Microsoft says so, and I think I believe them. And permissions, when it comes to switching, whoever or whatever, if it's an automated process, SQL agent job, whatever it is, it does require an alter table permission, because the partition switch literally is an alter table statement. Now you can have DDL triggers on your database, and these will capture the partition switch because it is an alter table operation. And we actually have these in place, and I have seen these triggers fired with my own eyes. So it really does work. So these aren't all the rules, but they're kind of the ones that you'd most need to be aware of. Read up on the Microsoft blog for a fully comprehensive list of the fun. So now that we've gone through all the rules of how to make this work, we just kind of go through a few gotchas. I mean, this is the good and the bad, and some of these can be kind of ugly if not done right. Yes, I know there is some repetition in here, but some of these definitely need to be stressed. So keeping in mind when you are doing any sort of partition strategy for any sort of reason, it's a metadata operation. And I hope that kind of fully answered the question from earlier. It's fast. It does create a transaction, and it does create a very brief lock during the switch, but the key is brief. The merge or split of a partition range can result in data movement if there is data in the ranges being merged or split. So keep this in mind. Data movement, if it's 1 or 2 records, it'll be quick. If it's a couple of million records, it can take a while. It can put load on your server. It can cause significant lock-in and block-in, and this can have an impact on anyone trying to consume this data. If there is no boundary range for a specific record, for example, my partition table has been defined up until the 1st of August, and it's a range right, therefore it's less than the 1st of August in that range. Anything greater than or equal to the 1st of August is going to go into the rightmost partition, which has a null rightmost boundary, and some folks call this the null partition. And this is where the above point can come into play. If you don't realize that you've run out of partition ranges, you're going to keep writing into this rightmost null partition. At some point, you're going to realize this, and you're going to have to split off ranges to properly allocate the data. And this can result in data movement and lots of pain, and probably a fair amount of swearing. But there's ways to get around it, maybe switch out the data into a staging table before splitting the partitions and switching it in. But if you get into a situation where you have run out of ranges and you're in a runaway partition scenario, it can get quite ugly and kind of complicated to fix. So try not to get into that situation. In an ideal world, your final partition should always be empty. If there's no right boundary, that partition, it's best to keep it empty. Cleaner and neater. More considerations. Nulls. Nulls and partitioning are generally not recommended. I have actually seen the scenario and it caused some head scratching for a while. If your partitioned column is null, if the value on this record is null, the data is going to go into partition number 1 on the leftmost side, because null is smaller than whatever your minimum boundary is. And if you're using partitioning for like a data retention archiving strategy, this can complicate things, because what's going to be contained in your oldest partition, it's going to be your oldest data, the data you want to archive. But now if you're using a date column, for example, and this date isn't populated because it's still active, the data is new, it's fresh, that's going to go into the same first partition. And if your maintenance is going to go and happily switch out partition number 1 and archive it off goes your fresh data as well. So not necessarily a situation you want to find yourself in. There's a but here as well. So you can specify a boundary value of null. So you have a null boundary and then you have a value boundary. In this case, if you have a record with a null partition column, that record is going to go into partition 2, and the first partition with a null boundary is always going to be empty, which is kind of pointless. So a recommendation I'd say from most architects and DBAs out there would be, don't make your partition key null. Don't even make it nullable. Force it to have a value so that it has a place, because everyone and everything wants to belong somewhere, right? Even data. So, more things to keep in mind. This list never ends. The more partitions you have, the longer your overall maintenance can be. And this is especially true if you're doing partition level maintenance, because now you have more partitions to maintain, reorg, rebuild. More partitions means more operations, means more time. Makes sense. More partitions you have, the longer also can be DBCC operations like checkDB and checktable. Conversely, if you do have more smaller partitions, your maintenance can be limited to individual partitions. And this can be particularly powerful where you have current data that is changeable, but where your old data is essentially never modified again. It's never updated, never edited. So in essence, your old data is read-only. So why do we need to do reorgs and rebuilds on data that's not changing? Ignore those and only do index maintenance on the few partitions that need it. Speeds up your maintenance. Again, depending on how you are writing your index maintenance, and keeping this in mind to leverage the power. Also depends on the SQL Server version. Keep in mind as to whether or not your partition level operations are possible and whether they can be online or offline. So keep that in mind if you're using maybe older versions of SQL Server like 2012 or 2008. There are different rules for older versions. Now, this one over here has a little star against it because I haven't tested this out myself. I'm taking Microsoft's word for it. But Microsoft says that non-aligned indexes can require more memory when you are doing maintenance on them. And they have some examples there about a non-aligned versus an aligned, and it was something like 100 times more memory needed for a non-aligned index. So take their word for it. That sounds bad. I don't want to try that. And also, as mentioned, if indexes on a table are not aligned, it can cause trouble for partition switching because rules. Okay, keep an eye on the time here. We've got 6 minutes to go. Yay. Not running over, that's good. More gotchas. Oh my God, they never end. Okay, partition elimination. It's been mentioned before and it has to be mentioned again. It can improve or degrade performance on your queries depending on whether you use it or ignore it. If your table is partitioned, you should always use partition elimination wherever possible. If you need to tweak your query, get your developers to tweak your queries to leverage partition elimination, do it. If at all possible, do it. You're going to reap the performance benefits of it. Not using it can have an adverse effect, and no one wants slow queries. And even when you're joining to partition tables, try to use the partition key, because any index, clustered or non-clustered, is going to include that partition key, whether you have specifically defined it as a key column or not. It's gonna be in your index, so use it. And when you have a very, very, very large table, which are the ones most commonly targeted for partitioning, stats sampling may not scan the full table. It may not scan all your partitions. So keep that in mind if you are having some performance issues. Check your histogram. It may not be entirely accurate, but you're going to have a similar problem if you have an unpartitioned large table as well. Default sampling is not a full scan on very large tables. And we're nearly there, I promise. When we're looking at newer versions of SQL Server, they introduced this really, really awesome concept of partition level truncation. This is really useful when looking to clear out old data, but notice here that the syntax is a truncate table syntax with a with partitions clause. If you accidentally forget the with partitions, especially if you're building this dynamically as part of an automated maintenance, you're not going to truncate your oldest 5 partitions or oldest 6 partitions. You're going to truncate your table. That's not good. So be careful, treat with respect. There are definitely scenarios where you want to use a truncate partition. I've used it myself, but you definitely want to be careful about it, is my advice. Check, double check, triple check, and check again for good measure. And last but not least, when you're using partitioning, when it comes to old data that is accessed infrequently, you can put this data on read-only file groups, but when you're doing any sort of maintenance, those file groups are not updatable. So this includes things like rebuilding and reorging indexes. By default, if you don't specify anything, a file group is read-write. So yeah, that is kind of the biggest what is partitioning. I've just kind of included a few DMVs.
Hey, Angela.
Yeah.
Real quick, sorry, we had a question. Does the partition, this comes from Mark, asked the previous question. Does the partition column need to be part of the primary key?
It does, I believe.
Yes.
It does, I believe.
Okay, thank you.
Primary key if the primary key is clustered, definitely yes. I always get the two confused whether it's going to be part of the primary key or the clustered index, but definitely if your primary key is clustered, yeah, you have to explicitly specify it. For all other indexes, it gets included implicitly if you don't specify it specifically. Generally, a good idea just to keep it there for visibility anyway. Okay,
and do we have time for one more quick question?
Yep, if there's anything there.
Okay, we have one more that just came in, and this is from A.S. Kaufman. Have you found partitioning successful in OLTP versus OLAP DB models? Do you have a general rule of table size before you will consider partitioning?
Okay, the OLTP, I don't really deal much with the OLAP side of things. With the OLTP, yes, we actually use partitioning on transactional tables in our primary database. in our OLTP system. It works very well if used correctly. Get a lot of performance benefits from it. Also, that makes the maintenance nice and light. And so, what was the second part of that one?
Do you have a general rule of table size before you consider implementing partitioning? That
one's a hard one. There's no, I'd say, rule of thumb. It's very much going to depend on your system's capabilities, the performance of it, your data load, how the data is used. Like, I wouldn't use partitioning on a small table of 1,000 records. I would definitely consider it on a very large table of terabytes. But size should be one of the factors and not the factor. You should look at other aspects such as maintenance as being more important than size, because a good indexing strategy can give benefits over just partitioning. So it's a combination of factors, but I'd say maintenance should weigh in maybe more than just sheer volume.
Okay, excellent. Thank you. We did real quick. We had a follow-up question back from Mark. The rule about, so is the rule that the partition column needs to be part of the clustered index, but not necessarily the primary key?
I will need to verify that one. I don't want to give you incorrect information. I'm confusing myself now, overthinking this. Definitely clustered index, yeah. Primary key, I will pop back onto Slack and verify that before I get myself into too much of a muddle here.
Yeah, that question came from the Slack channel. So afterwards, if you want to check the channel, you can reach out to Mark directly.
Yes, I can see it over here. Cool.
Thank you. Carry on.
Great. Anything else? I've gone 2 minutes over time here.
I think that's it. So I would carry on.
Cool. Yeah, I'm done here. I've just listed a few objects here, which I'll upload the slides.
You have another 13 minutes till the next session, Angela. So you got loads of
time. Yeah, no pressure to fill the gaps. No pressure to fill the gaps. So all I've kind of put on here is just some useful objects to use when looking through your partitioning strategy in your database. Partition functions just list the functions you have in your database. Partition parameters will tell you which data type that function supports. Range values actually gives you your boundary values, and both of these tables have a one-on-one link to your, or one-on-one for parameters and one-to-many for range to your function. Partition schemes, you can have multiple schemes to your function listed in partition schemes. Sister partitions is your actual table partitions rather than the general storage object. Destination databases, or data spaces, is just a table that links your partition scheme to your index and your file group. Partition scheme. It links your index to your file groups. So it will say, okay, well, in this index, partition 1 is on this file group, partition 2 is on this file group, etc., etc. Destination data spaces. When joining, always have the partition number joined, or you're going to get a bit of a Cartesian product. Sister file groups, obviously your file groups, which links to your physical files. Partition stats just kind of gives you some detail on the page counts, your rows, etc. in your partition. And then you've got the dynamic function for partition physical stats, or index physical stats, but it actually contains partition level detail. And that'll give you your number of pages and also your fragmentation. And this is used by maintenance solutions such as Ola Hallengren's uses this DMF to determine which indexes and partitions are eligible for rebuild or reorg during partition maintenance. So this would be where it comes from. So it's a good one to be aware of. So just a quick credit to an ex-colleague of mine, Colin, for going through this and just validating this when I first created this slide like 3 years ago. And also giving me some ideas just for the theme. And of course, no one would be anywhere without all the amazing blogs and online resources. So I've listed a few that I've found particularly useful. And Andrew, you've made the cut. Your blogs are pretty awesome. They're super easy to follow and definitely worth bookmarking for people. So yeah.
Cue smug face over here. Thank you.
Good information. Deserves a shout out.
That was an excellent session, Angela. Thank you very much.
It's my pleasure.